and they would kind of come very prefabricated in a way where we could save a lot of time, and we tried to really use a lot of materials that we already had on hand to save the cost where we could, to just make everything simple. And so the last 2 years, we've had a lot of progress. We've really seen how success really is not guaranteed. So for us, you can see in 2023, that's a robot in the bottom right. I don't know how well you can see it, but it was pretty much a robot built on our hopes and dreams. We were just hoping that it would get through each competition. Every match, we were working on the robot, fixing it. There were screws loose, screws broken, parts broken, wires were just completely dismembered. We actually only had 3 working wheels. We had a caster wheel, just like a shopping cart, just in one corner of the robot. Really have to get scrappy. So 2024 came along, and we really had to decide we're gonna really have to be really careful, and we really made an effort to really design and develop a really highly, well-manufactured robot, and really put a lot of intention on everything. And with that, you have that really important factor of the design, having everything you have that idea already fabricated, you know the measurements, you know everything, you know where it needs to go. But even then, that doesn't guarantee you success, just because of the fact that you don't always have the money to do that, and you don't always have the time to do that. So for us, we built this beautiful robot in that top right corner, but it didn't necessarily have the time to be developed with programming and just a prototype.
So the build season for robotics is only about 2 months, between a month and a half and 2 months, from the beginning of January to the beginning of March. It's all the time we have to build this. This year the game was called Reefscape. It was a water-themed game. We have one of the elements here to show you later after the presentation. Essentially the way it worked is we have these little segments of PVC pipe.
You are awesome. So I hope everyone can hear me well and see me well. So my name is Lucas Picard. I'm the team captain of the Panther project. We are Team 2064. So that is really just our team number. Every single team is assigned a specific number, and that's why you see 2064 up there. And then this is Matt.
Yeah, Matt Whitmire. I'm the co-captain / build captain of the team. The reason they do numbers is because there's probably like 15 different Panther-related names, and it's just a good way to differentiate them between them all.
And now we also have thousands and thousands of robotics teams throughout the world competing. So, that also creates a reason for the numbers. All right. All right, okay. So we compete with robotics through the first robotics competition. So it's a very specific kind of robotics, group. And it's essentially created to let high schoolers compete with robotics, to develop their design skills, their build skills, design with anything STEM related. So you see, something as simple as a STEM with your science, your math, your engineering, your art, your design, anything you can think of. But you also have things like business and your social outreach. Events such as this, events where you're doing fundraising, so it's all very important, all through First Robotics. So our robotics team is completely student-led. You have Matt here, you have Ethan, you have lots of other, student captains that you don't actually see today because they're very busy. And it's actually, school just ended just about an hour ago. So we wanted to rush here and come talk to you because we find that very important, especially to you guys. You are very important to us as you're just part of our community, and being able to share what we do is really important to us. Our whole program is very important that we think in kind of developing this idea of gracious professionalism. And what that essentially is just this idea that we're going to compete, but we're going to do it really respectfully. We're going to be kind, and we just want to do it in a way where everyone is kind of competing as friends, not necessarily as enemies. So it's essentially a lot of fun.
So why do students compete in and participate in the FRC program? A lot of that comes down to just the way it's operated. It was originally created way back in the late 90s as a way for like the whole STEM field and engineering to have like a competitive area, similar to other varsity sports like football or soccer or baseball. Because there was nothing quite like this before they created it. And it's just a very fun way to build upon skills that you learn. You are applying your math skills, your engineering skills, your business, your outreach, all that, and you're using it in the real world, in a real setting, very comparable to an actual job at some point, especially during the busy parts of the season. Yeah, so it's just a fun way to express all these skills. Sorry.
So, I guess we'll start here. Our robot is able to utilize a completely two-dimensional driving system. It's not like your normal car where you only have two wheels that can steer. All of the four wheels are driven and can kind of rotate in any direction. So I'm able to move in all directions. At the same time, I'm also able to rotate while moving. And so this allows for a higher level of performance while competing. So I'll show you kind of one of the versions of what it looks like to actually pick up the PVC pipe, the coral, for our you got level 2? Sounds good. Our level 2 scoring position. I don't know if I'm lined up here just because normally we do this all autonomously. So you can see, I'll pull the robot back a little bit. If you, Ethan, rotate the reef a little bit out towards the crowd. So you can see there's almost a QR code looking black and white sign. And so what that allows us to do is use our two cameras. We have two cameras on the robot, one right here and one right there. And that kind of allows you to see where the robot is on the field and then automatically drive to the reef. And that just allows us to have an increase in performance where we're automatically driving. That removes some of the load from me where that increases our accuracy. I'm probably just going to leave it just because of I don't want to ruin and create, rubber tire marks on your beautiful floor. We have events where we'll just completely tear up our tires and we'll have rubber all over the ground. So we do leave marks if we're not careful. We store our coral, our PVC, right in the head right here. We have a sensor that kind of detects if the PVC pipe is in the robot or not, and that kind of creates more automation. So this robot, we try to really advance our programming, our automation, and just make it more intellectual, just make the robot smarter, so that it would increase the performance once again. So I'll go into another. When we compete with this robot, we don't just deal with the robot itself. It's not just scoring, the PVC pieces on the reef. It is an offensive but also defensive game. So you have 3 robots on each team competing against each other. It's the same field. It is a little bit separated because you do have the cages, but that does essentially mean that our robot sometimes does end up on the other side of the field where we're playing defense. This means that we're kind of really pushing our robot into other robots, trying to get in their way, trying to stop them. It really is, everyone asks, oh, do you do battle bots? No, we don't do battle bots, but we do have defense. And that is very important for robotics. It essentially will allow you to slow other teams down. It is really a pivotal role, especially in this game where you can see you have this PVC piece, and it is a little bit hard to grab that piece sometimes.
And like I mentioned earlier, of course, we don't have the whole setup to climb here. You have a picture of it there up in the bottom left of it when it's up. You want to go through the cycle of climbing. And you can see the kind of motion it takes. We'll back into the skill page in this position. Once we are set by what he can see, it does it very fast, but you might be able to see it has 2 clamps on it that will clamp down on the edges. And then at this point we would be in the air. And then finally we have like a little winch that holds it in place after the game is over. And that's pretty much the entire game. We'll just do that. We'll score there for about 2 minutes. We'll climb. It takes us about between 5 and 20 seconds, depending on how much time we're going to give ourselves. And then we win, hopefully.
Yeah. So one of the big things about this climb mechanism that you see right here is this was really important to us as a team. We really wanted to make sure that we can always climb. That's really important to us. That is pretty much essentially a way that we can essentially guarantee a ranking point. So that's very difficult. To guarantee ranking points is something that you don't have often. But what we had this year is if you have the hardest version of the climb, if you go for it, you're able to get enough points where essentially you do have that guarantee. So that became one of our biggest priorities. And so we have a very specific design that you don't see with many other robots, and we pretty much have maintained a really good record where we almost climb every single time at CT Champs. Every single match that we played, if our robot was on, we climbed every time. That was something we always guaranteed. That was just something we say. Panthers always climb. That's kind of one of our sayings, and that's really been important to us. And so essentially we do have moments where you have 10 seconds, you have 8 seconds, and you realize, I need to go and I need to climb. I don't know if I have enough time. I don't know if the robot is going to really get there in time. These